So the number 197. And what I'm going to do is I'm going to add the 3 digits. So 1 plus 9 plus 7 is 17. Now what I'm going to do is I'm going to form a number out of the last 2 digits of the original number and the new number. 9 plus 7 plus 17. And that is 33. And now I'm going to do the same again. So it's 7 plus 17 plus 33. And that gives me 57. You're beginning to get the idea. 17 plus 33 plus 57. And that gives me 107. And now, Brady, you've been very patient. The Keith number is about to emerge. 33 plus 57 plus 107. And look what I get. When I do that, I get 197.
That's quite interesting. Like, I can't decide if these would be really, really rare or really, really common. Intuitively, it strikes me that this would be rare.
They're very rare. This is a number with 3 digits. There are only 80 of order 80 numbers, 80 Keith numbers, with less than...
Of order 80? Hang on, I don't like this of order.
There are, in fact, 84. 84 Keith numbers with less than 26 digits.
Once you get more than 3 digits, how do you start this process?
Say you talk with 2, 7, 8, 5, for example, then you would begin your process with 2 plus 7 plus 8 plus 5, which is equal to 10, 17, 22. And the next stage along the line is you take the preceding 3 digits and add the 4th from the new number. So it'd be 7 plus 8 plus 5 plus 22. There are, for example, 2-digit numbers. Okay, so if I take d equals 2, then 14 is a Keith number. You go 1 plus 4 is 5. 4 plus 5 is 9. 5 plus 9 is 14. Mike Keith, who's a mathematician, and discovered them in 1987. For me, this is recreational mathematics. It's how I got into mathematics. My hero wasn't a physicist early on. It was actually a guy called Martin Gardner. I'd never heard of Euler, sadly, earlier on when I was at school and Gauss, but Martin Gardner was this guy, brilliant mathematician that worked. I knew him as the guy working for Scientific American. And I subscribed to Scientific American, and I never understood a single article I read. I kept trying to understand. I'd reread it, and it'd be a blur. But the mathematics, he had this mathematics puzzles at the back, and then I generally couldn't do them either, but I was fascinated by them. They were little numerology things. And then I went and bought some of his books and just got into it, just playing around with numbers, and you just get to love them.
So the people who watch Numberphile and get a bit sniffy about our recreational maths videos, what do you say to them? Oh,
you shouldn't. You should just enjoy it, embrace it, and just have fun. Just have fun playing around with them. There's plenty of occasions when you're doodling, thinking, what shall I do? And just play around with numbers, and you'll be amazed some of the coincidences that can come up, and out of some of these things come major breakthroughs. We're not quite finished. There's just a couple more things which are around there. There's one called the reverse Keith. And this is where, so again, it's best just to show you an example of a reverse Keith number. It's where the reverse number appears in the sequence. So if I begin, say, with 12, okay? So and we just follow the prescription that we've had. So we go 1 plus 2, 2 plus 3, 3 plus 5, 5 plus 8, 8 plus 13, and that's equal to 21. And that's your reverse Keith number. You've reversed the order of the integers in the original. There's even fewer of what you could call Keith clusters. Keith has got a conjecture about these Keith numbers, his numbers. He's allowed to have a conjecture about his own numbers, of course. And they're to do with the clustering of these numbers. And what he's done is he's said, how many ways can you cluster the Keith numbers such that in any cluster, which could have of course, a cluster has to have more than one number, so it could have 2 numbers, 3 numbers, 4 numbers. Each number in that cluster is an integer multiple of the lowest number. His conjecture is the following. There are 3 that are known, just 3, and he says he believes that's all there are. So I think it's quite an interesting challenge for some of the numberphile people to go and maybe find some more. So
what's a Keith cluster?
So here's an example of a Keith cluster. So the number 14 and 28 are both Keith numbers, and of course 28 is twice 14. And another Keith cluster is the number 1004, or 1104, and then if I double that, 2208. We've also got to have the same number of digits in the sequence. There is remarkably one cluster of 3 Keith numbers, which is 31331, of course 62662, 93993. I think that's amazing. Each of those are Keith numbers. They all satisfy the properties that we've been describing, and they form this cluster. So the conjecture is that's it.